Hey there, take 1 second to hit and smash that like button and let's get started.
All right, so neural networks. This is something we'll get into heavy. We have 86 billion neurons in the brain. That's a lot. And we have about 1,000 trillion synapses. That's almost infinite amount of data. So what I mean by that also is measure a bee. A bee has about 1 million neurons, and the level of complexity of the bee is pretty simple. Eat food, do whatever it needs to do. A dog has about 530 million neurons as well, which is an order of about 160 times less than we do. And that allows us to think at the level we are. So imagine if there's a system who had more than 86 billion neurons. What kind of level of complexity would it have? That's what they're trying to work on in AGI. So moving forward. So we're going to get into some deep stuff here. So neuron core is broken up into parts. There's the dendrites, there's the axon, there's the cell body, and there's the synaptic part at the end of the axon, where it allows you to be able to connect from one neuron to the next. And you'll learn this in neural networks, but this is just something that works in our brains currently. A little more detail about that. So I made the connection between how it's done in artificial neural networks versus how it's done in our actual physical brains. Again, dendrites, cell body, axon, and a terminal axon is what we call here an activation function. So when once the cell body says enough axon potential goes through this system and turns on and sends the signal across, it actually charges and creates an activation function in the neuron, and you see it over there, the f of x, and it sends that signal forward into the next neuron. And you can see down here, between them is something called synapse, or synapses, or between the two, the dendrites, or the axon here, axon terminal, and the dendrites on this side. And in the middle here, you can see that this typical neuron or a neural network you see if you work in this field, you'll see those connections there. And these lines here are the actual synaptic connections. Those are in our brain, we have about somewhere between 100 to 1,000 trillion connections between the neurons. It's a lot. Okay, so here's a little model of how make a prediction from one item to the next, to the next, to the next using a neural network. This is DeepMind's version when they were working on like initial AlphaGo. I'm not going to go into that because everyone talks about that. But you can see here, it spreads out, makes one decision, that's the best decision, and go from there. So it's something we call data explosion. It's just a significant amount of data that can be computed. That's why you need large machines to compute this level of networks. And this is a feed-forward artificial neural network. And we'll talk about what feed-forward and backprop means in a little bit. Any questions? Is it a lot so far?
It's a lot.
There's a lot more. So we have in here in this neural network a system where each one of those green items up there are inputs. And each one of those green items are like, for example, a feature. They call them feature sets. And a feature set can be, for example, I identify a person. One feature set can be a hair, the hair color, the shirt they're wearing, the facial expressions. And you'll see this in artificial deep neural networks. Each one can be some level of input that's signaled through to get me to identify a person, for example. So I send a person through, the network will figure it out, and then at the end will give me an answer or a solution to whatever it is I'm trying to figure out. And typically we use something called supervised learning for this, because we send a value in and we get an output out. Simply put, same thing, goes through, computes the values, output. And this is a loss function. You guys are familiar with this concept, which is basically just going through, backpropping through the entire system and literally going back to the very front again, making a correction to it. So to make that kind of connection, you learn something, right, and someone smacks you in the hand and says that's wrong. Well, it goes through the whole system, figures out, okay, what did I do wrong, and do it again. This loss function kind of denotes that in mathematical terms. All right, so for a back prop, you see here it's going forward, they're going to send it back. Basically correct what it saw to fix it, and then that's where all the math comes in using partial derivatives. And does that over and over again so it feeds one input, set of input in, goes through the system, figures out, make the correction on that, and then send that back, and that's one cycle. That's one cycle.